Hello, everyone, and welcome to the Scaling Ethereum 2024 Arbitrum OffchainLabs workshop, Arbitrum Stylus, Write Smart Contracts in Rust. And joining us today is Jose FP, who will be taking us through this session. And with that, I'll pass it over to Jose to get the session started.
Right, thank you. And hello, everyone. So yeah, we are going to talk today about Arbitrum Stylus. We are going to see a bit what it is, and we're going to see a few examples of this technology, okay? And let's get started. Well, first of all, I'm Jose Franco. I'm an integration engineer at OffchainLabs. And well, here are my Twitter and Telegram handlers in case you want to contact me. I don't write a lot on Twitter, but you can contact me there if you want. And OffchainLabs are the initial builders of Arbitrum 1 and Arbitrum Nova chains and the developers of the technologies Arbitrum Stylus and Orbit, okay? If you don't know any of these terms of technologies, I invite you to go to our Discord and ask about them. We'll be more than happy to answer these questions, okay? So, okay, this workshop is going to be divided into two parts. The first one is an introduction to Stylus. We're going to see what is a stylus and a small example contract written in Rust. It's a counter contract. And then the second part is going to be a bit more complex because we are going to talk about interactions between contracts that are written in Rust and Solidity. How do we make these calls? We will talk a bit about re-entrancy, which is a bit different in Stylus. And we're going to see another example project. So what is a stylus? Stylus is an upgrade to the traditional smart contract development environment. That means that currently, if you want to write a smart contract for an EVM chain like Ethereum, Arbitrum, you usually use Solidity. You usually write your contract in Solidity, right? Or Viper. You can also use Viper. So Stylus allows you to use all the languages to write those smart contracts. You can write them in Rust, C, C++, and many other languages. And this is possible thanks to a new virtual machine that executes WASM programs, lives alongside the EVM, and is actually interoperable with it. That means that Stylus contracts can call Solidity contracts and the other way around. I want to give you just a few numbers to understand what this means. So there are around 20K Solidity developers, 3 million Rust developers, and 12 million C++ developers. Well, these are numbers from a year ago, more or less. Probably numbers are different now, but relation between them is going to be close. So one of the main benefits of Stylus is that now developers that know other languages, they can start developing smart contracts without needing to learn a new language. Okay, so yeah, developers are now free to use the language they want to develop smart contracts and access the blockchain ecosystem. Another benefit of Stylus is that it increases speed, it reduces cost, basically because generally WASM programs are more efficient than their counterparts in Solidity. And also another benefit is that memory usage is improved in Stylus, and this allows for new use cases like advanced cryptography, for example, generative art. So right now we are developing an SDK for Rust. There is another one for C and C++. And we are developing these SDKs to make smart contract development in those languages easier, right? But basically, today, you can use any language that can be compiled to WASM and deploy a smart contract in Arbitrum Stylus. And actually, there are examples of programs written in assembly script and C that you can find in OffchainLabs repositories that are actual contracts that can work in the blockchain, right? So right now, Stylus is in alpha version. There is a testnet where you can deploy your contracts, your Stylus contracts, and we are finishing several audits in the core code of Stylus. And there is right now, I think it was submitted like yesterday or 2 days ago, a proposal in the Arbitrum DAO forum for activating Stylus on Arbitrum 1 and Nova. So it's actually, you can see that it's in its final stages already. And as part of that proposal, there's going to be a snapshot vote to activate Stylus on Arbitrum Sepolia. And well, this is also going to be part of the Orbit chains later. All right, so how do we start with Stylus? These are 3 resources that I like to give developers who are just starting out. For these resources, don't worry about searching for them right now, because at the end of the presentation, I'm going to show you a QR code that has a link to a repo that contains all these resources that we're going to see today, and I'm going to share that also in the Discord server of ETH Global later, okay? So the first resource is a quick start. This is actually a page in the public documentation of Stylus that goes through how to set up your environment and work with a Hello World contract that is written in Rust. So you can see a bit how it feels like working with Stylus. Then the second one is a Stylus by example. This is a series of pages. It's a small portal of pages that contains information about certain things that you can do with Rust in your smart contract, specific to blockchain development. Like, for example, how do you emit a log in your contract? And Awesome Stylus is a repository of that contains a lot of resources that are related to Stylus, like contracts, projects, talks, all that. So that's another useful resource to start. And okay, let's see a first example of a contract written in Rust. We're going to see a simple contract that just holds a counter and allows you to increment it by calling the different functions. So let's take a look at it. If we come here, I hope you can see the code well. So this is a simple Rust contract. This is a Stylus project. As you can see, it basically has only one lib.rs file, which is not very long. And what we do is actually we start importing the modules that we need. And then we start using these macros that are specific to Stylus, okay? So the first one is Solidity storage. This macro tells Stylus that we are going to define the storage layout for this contract, okay? So in this case, we are using this struct to define that storage layout, which only contains one count variable here, a U256. And then the entry point tells Stylus where the execution of the program actually begins. It begins with the storage definition, right? The next one is the external macro, and we are using it here because we are defining or implementing the methods that are going to be called externally from this macro on. So that means that these 3 methods that we have here, get, set, count, and increment, are external methods. If you want to implement a method that is to be used internally, you can just implement it before the external macro, just to give you an example. And this contract has just 3 methods. A get method that returns the count variable that we have in storage, a set count method that sets the count to a new value, and an increment method that just increments that count by 1, okay? So one thing to notice here is that look at this set count method, for example. We are using here Rust syntax. That means that we are writing the method name in snake case, right? But when we call this method, when we deploy this contract and then we call it in the blockchain, we are going to use the same syntax that we use when we call a Solidity contract. So we are going to use camel case to call this contract. We're going to see now an example of how to call it, okay? But just so you see that when calling a Stylus program, you don't need to know that it's actually implemented in Rust. You call it the same way you call a Solidity contract. So this project has also several scripts to perform individual operations in the smart contract. So, well, it has a deploy script, but then you have the get count, the get count, for example, just to cast call to the contract and calls the get method. And the set count, for example, well, that's the same. That's a cast send because we're changing the storage. And as you see, we use set count here to change the value. As I mentioned earlier, when we call the method, we use camel case instead of snake case. And actually, we call it the same way, we would call a Solidity contract. Okay, so let's take a look at the deploy script as well, just to show you something. Another thing, when using Stylus, this is all explained in the quick start, but just so you know, to deploy smart contracts, we usually use this tool, this Cargo Stylus tool, which has different commands that you can use to work with your contract, with your project. You can check if the contract can be compiled, if there is any compilation errors, or if it is compatible with Stylus. You can estimate the cost of deploying the contract. And in this case, we are just using the deploy command to deploy the contract, right? This is all, I don't want to get into too much detail, but this is all explained in the quick start. So let's, for example, deploy this contract. Okay, so this is now deployed. We have our contract address here, and we are going to call get count. I have this comment here to make my life easier. This project, this code is also going to be available in the repo that I'm going to share at the end, okay? So you can actually use that. Okay, so the counter is 0 because we just deployed it. So we're going to increment it now. Increment, I think I haven't shown this. Increment just calls the increment method and then the get method. So this is the transaction, which was executed successfully. And then we have the new counter 1. And we can also verify with get count. There we go. All right. So this is the counter program. Now, let's go to the second part of the presentation. This is a bit more complex, but well, it should be okay. How do we interact with other contracts? How does a Rust contract written in Rust interact with a contract written in Solidity, for example? And the main thing to understand here is that, Stylus calls are Solidity ABI equivalent. This means that when you are calling a Stylus contract, you don't need to know that it is a Stylus contract. You will call the methods the same way you will call a contract written in Solidity. That's what we mean by ABI equivalent. The interface that you are going to use to access those contracts is actually the same in both cases, okay? And how do we actually write code to interact with, to call another contract? So in Solidity, what you do is that you import the interface, and then in the method where you want to call, to make that external call, you just use that imported interface to make the call, right? So in Rust, it's basically the same. You import the interface with this instruction, this macro, so interface, and then you configure and make the call with the call module. Let me show you an example. So this is actually Rust code. So this is part of a Rust program. So in this case, we are importing an interface of an ERC20 contract. And actually, you can see that we've written here the signature of the function in Solidity, basically. And this is the way we actually import interfaces, okay? So we are just importing the balance of function of the ERC20. And yeah, we do it that way. We use the Sol interface macro and just import the interface there. And when we make the call, we create the variable using the interface that we just imported. We create a new configuration for a new call, and we just make the call with calling that variable ERC20.balanceOff. We pass the configuration that we created back here and the parameters of the method that in this case is just an account. Another thing to note here is that when importing the interface, we use Solidity syntax, meaning that ABI syntax more specifically. So we use camel case for the balance of function, but in here we are using Rust syntax. We're using balance of in snake case, okay? So the code that you write is actually all Rust. And yeah, when making a call, you can actually configure the different properties of the call using the call new method that we saw before. You can specify a different gas property or different value that you want to send in the call. Okay, so let's talk a bit about re-entrancy. So re-entrancy, remember that re-entrancy happens when one contract calls another contract, and that new contract calls the first contract again. So in that case, we say that the first contract is being re-entered. There is re-entrancy happen there. So by default, a stylus program will not allow this. So a call that re-enters another the same contract again will revert, okay? However, this can be activated by enabling a feature flag, the re-entrant feature flag. And when this happens, the stylus will flash the storage cache in between calls and will persist the values to state, okay? So we can use them in the inner calls that can be done with call new in, okay? Another cool thing about this is that you can actually implement different logics inside the same method for when you know that the call is being re-entered or for the first time. So you can check the value of MSG re-entrant and say, okay, this is a re-entering call, so I apply a different logic in this case. Okay, these are two resources that have more information about that. And let's now jump into the code. So this project is a bit more complex. We have 3 contracts here. We have an NFT contract, an ERC721 contract that is written in Rust. We have an art contract that is written in Rust as well. And we have an ERC20 contract that is written in Solidity, okay? And the way they interact is that the NFT first is going to initialize both the other contracts, and initialize here means that they are just going to share the addresses of each contract, so they can store them in their storage. When calling the token URI method in the NFT contract, you know that you usually get an URL from that call. Well, in this case, the contract is going to generate an image, but it's not the NFT contract that will generate the image. The NFT contract is going to call the art contract to generate the image for them. Okay, so this is the first interaction. And the second one is that we've added a sort of limitation to minting an NFT. And that limitation is that you need to have a certain balance of ERC20 token to be able to mint an NFT, okay? So those are the interaction here is that the NFT, when minting, is going to check the balance in the ERC20 contract, all right? All right, so let's take a look at it. Okay, this is the one. I'm going super fast because I want to show you guys many things. I don't have a lot of time, so sorry about that. But you are going to have all this code later to be able to go through it at your own pace, all right? So in this case, in this repo, this is the actual repo that I'm going to share later that has all the resources that we just talked about. So we see here that we have several folders, and the contracts are stored in the NFT folder, the art folder, and the ERC20 folder. The NFT folder is a stylus project and has 2 files, 2 Rust files, an ERC721 file, which is just an implementation of the ERC721 standard. And we have the lib.rs file, which is the main file that imports that implementation and creates the NFT, okay? So in here, for example, you can see that the storage layout is a bit different. We are borrowing here the storage layout of the ERC721 contract and adding the art contract address and the ERC20 token contract address to the storage. So the methods that we have as I said, this is more complex. If you have any doubt about any specific part of this contract, just go to our Discord or ETH Global Discord and in the Arbitrum channel and ask the questions there, and we will be happy to answer, right? Okay, so for functions, we have the minting functions, mint and mint2. We have the burn function, the token URI function, and the initialize function, okay? So for the art contract, which is also written in Rust, these, I'm not going to go over all the files because these are just files that has like image generation methods. But the important one is the lib.rs file that contains the actual contract, the actual art contract, right? So we start with an internal gen art function that just manipulates the image, well, generates the image that we want to generate, and the rest of the external calls. So the storage in this contract will just store one address, which is the NFT contract address. We're going to see why we want to store it here. And the methods that we have are down here. But basically, we have a generate art and a generate art with owner. And another thing that I wanted to show you here is that we are using this special macro, this selector name macro, that actually has the same name for both of them. And this means that this tells Stylus that when calling this contract, we are going to execute those methods when the generate art method is called, okay? But we're going to execute one method or the other based on the parameters that we are sending to the call. So if we are sending only a token ID, we are going to execute this function. If we are sending a token ID and an owner, we are going to execute this function, okay? And to understand a bit more this, the image that this contract generates is based on two parameters. The token ID of the NFT that we are generating the image for, and the owner of that token, okay? And at last, we have the ERC20 contract, which is just a Solidity contract. It uses an implementation of the ERC20 standard by OpenZeppelin, and we have just added one function to allow it to mint the NFT from this contract. Okay. All right. So let's take a quick look at the interactions. Now, when we the interfaces. So let's take a look at the interfaces here. So let's take a look at how we are back at the NFT contract, okay? Hope you're following me because I'm aware I'm going too fast. So we are back at the NFT contract, okay? Who's going to call the art and the ERC20 contract. And we are importing the interfaces here. This is the interface for the art contract, and this is the interface for the ERC20 contract. And notice that they are actually imported the same way in terms of syntax used. The art contract is written in Rust, the ERC20 is written in Solidity, but they are imported the same way, okay? And to see an example of a call, when we go to token URI, down here, we pass only the token ID, right? So in this case, we get the owner of that token inside this contract, and then we call the art contract. We create the variable based on the interface that we imported, we create the configuration, and we just call generate art. So this generate art is going to execute one of those two methods that we saw in the art contract. But in this case, because we are using a token ID and an owner, it's going to execute the second method. So let's take a look at it. It's going to use this one. It's going to execute this one, okay? And well, this function, the only thing that it does is that it just generates the image, creates a PNG, and returns the base64 string of that image, okay? So the way we do this, why do we actually pass the owner here? Because the other alternative will be to let the art contract get the owner for us and just send the token ID, right? And that's what this function up here does. What it does is it takes just one token ID, it calls the NFT contract to get the owner of that token, and then generates the image. So if we go this way, if we call token URI, and then we call generate art, and we let this contract, this art contract, call the owner of the NFT contract, we will be re-entering the NFT contract. And in this case, we don't want to enable re-entrancy. That's why we've created the second method and passed the owner here, okay? This is one interaction. The other interaction of the NFT contract, let's go back to the NFT contract, is when minting. When minting, what we do is that we call this internal method, user has enough ERC20 token balance, and we pass the minter address. And then that function, what it does is it takes the account and it calls the ERC20 contract using the interface that we imported. And we call the balance of method of that contract to get the balance of that account. And if the balance is not enough to mint, well, we return an error, okay? So yeah, I have time to explain one last thing. There is one more interaction that we can see here is that if we go to the Solidity contract, we can also mint an NFT from here, right? So to mint an NFT, we've imported the interface for the NFT contract, and we call the mint2 function, which does the same thing as the mint, but we just send the address where we want to send that NFT, right? So if we check this function, this mint2 function in the NFT contract, in here, we are going to see that it makes the same call to user has enough ERC20 token balance and mints if it has enough balance, right? So notice that in this case, we are calling the Solidity contract, which is calling the mint2 method of the NFT contract. And the NFT contract is calling the balance of method of the Solidity contract. So the Solidity contract is being re-entered here. But this works. I mean, this is not going to revert because we are re-entering the Solidity contract, actually. Okay, so this is why, well, this is the difference that I wanted to show you in terms of re-entrancy, re-entering a Solidity contract and a Rust contract, okay? I don't have time to run through the scripts of this project, but we have also individual scripts to perform several operations in this contract. I invite you to go over them and execute them. And yeah, that's all. If you have any doubts, just go to our Discord server or ETH Global Discord server, and in our channel, in Arbitrum channel, ask all the questions that you need. Here is the QR code for the repository of this last project that we just saw, which contains a resources section with all the resources that we just saw. I'm going to paste this link also in the Discord. And I think that's all. I think we made it on time. Thank you very much for your time. And yeah, I don't know if I have time to go over questions if they have written something, Rory.
Yeah. I don't think there was a question. So give me 1 second. Can you explain about the qualification for winning the prize and what would be the good idea?
Oof. I don't know about good ideas. I don't remember now the tracks, but I can look that up. And if you are on Discord on the ETH Global server, I can actually write there the different tracks that we have or the different requirements for the Stylus track.
So, and then how is the Stylus on-chain activation check done through RPC? Is there a new method that is only available on the Stylus node? And where can I find info about it?
Yeah, exactly. There is a new precompile. Actually, it's called Arbitrum, and that precompile has a function that is, if I remember correctly, activate program. And that's actually the method that activates the program, right? So when we call cargo stylus deploy, it's going to deploy the bytecode, and then it's going to call that method in that precompile, right? You can find information about it in the Arbitrum documentation here, docs.arbitrum.io.
Okay. And there currently are no other questions, but if anybody else has any questions, feel free to take yourself off mute and ask now. We can spend like maybe another minute or two.
Okay.
But if there are no other questions, then yeah, what about auditing?
What about auditing? If you mean
Uh,
auditing stylus, right now it's I mean, well, not right now, but we've been doing many different audits on the core code of the stylus itself, on the virtual machine, and also on the Rust SDK. So yeah, right now we are finishing up the audit process there, and auditing these contracts. Well, that depends, I think, that depends on the company that you use to audit the contracts. I mean, they need to know Rust to know what's happening. But in terms of on-chain execution, that will be similar to what happens in Solidity. So on the other virtual machine, on EVM.
Awesome, cool. Well, yeah, I think we can maybe wrap it up here. But as Jose mentioned, feel free to reach out to him in their partner Discord channel. I saw that he's already active on that. So if you do have questions that you didn't get a chance to ask or didn't think of now, feel free to drop them in the Discord chat there. And Jose, yeah, thanks again for the great workshop and presentation, and thank you everybody for attending. And we'll see you all for another one here in about an hour or an hour and a half or so. So cheers, everybody. Have a good rest of your day.